already looking at the first two presentations, I think we have today an amazing mix of academia, practical application, robotics. So I'm really happy maybe to show another perspective from our side. My name is Vlad. I'm working for Accenture on the topics of industrial AI, and happy to share with you today one of, I would say, also my private research topics. I hope it will be interesting for you, and looking forward to get your feedback, and maybe also you would like to be part of this development. So maybe first of all, some information you can scrap from our homepage, which is public. Maybe some of you will be wondering why Accenture is in the circle and what we're actually doing in this space. So actually we have a very large footprint in industrial. It's kind of a new service line within the Accenture. You can go to our homepage and see some examples of what we're doing. So we had a number of acquisition in industrial space over past years. I'm also coming from acquisition. And we are involved in the areas from quality inspection, manufacturing, to robotics and integration of large PLM systems. And of course, topic of AI and now reasoning models, natural language processing, LLMs is one of the major for us at the moment. I'm also coming from translation management. So I was working on transformers since the paper attention is all you need. So the whole development is really, really interesting for me at the moment. And I would like to start with some comparison, and I think some of you already had similar feeling. This is one of the tools I think many of you know. It's a V0 where you can just prompt something and you will get the whole working web project just by using a prompt. And you see the magic here happening, just giving your input and different icons and screens jumping around your screen. And in a few seconds, you will get a full functional homepage or web project really validated and tested. And then I see some people then moving back to their business or to their companies and looking at their systems or in manufacturing to their plants, and they're asking like, why is this gap there? So what we should do actually to bring these capabilities to our home base. And the magic behind it is actually that it's not one LLM working in place. This is a whole team actually behind it. So some of you heard this development from large language models in the beginning, then to agents. And now we speak about Agentic AI. And Agentic AI is kind of a team set of different agents working together. This is a very rough summary of what's happening in a case before, where you have one orchestrator agent which tries to understand your requirements, then a set of requirement management agents trying to divide functional requirements, technical requirements, the navigation within your application and design. So normally it will be a set of 4 to 5 different experts working together and iterating. And from here, they pass over to the development team, which develop the code and validate it. And this is the important part. And they can run in a circle. And comparing to tools like ChatGPT, for example, you maybe also seen that it's not a one file which is developed, it's a whole web project consisting of several files. And later you can even deploy it. So topics like DevOps are here included. If you know this tool, we can share it in the chat. You will see it will spin off the whole new instance as a Linux server. It will install on dependencies and give you even a subdomain so we can access the link. So why is it so simple, and why we cannot bring it to our industrial domain this way? So I have kind of a provocative thought, which is in my mind for at least past year, that one of the reasons why we see such a rapid development in coding and software development lifecycle is that code compiles. So the system can directly get a feedback, and the reasoning engine understands what is right and what is wrong and can iterate over time. Of course, in the coding is a very rapid process and it's very fast, but this feedback is a crucial component of it. And the question I had is, if we can bring the same logic to industrial space, such as engineering or manufacturing, logistic, giving to the machines this feedback so they can iterate over time. If we think about this process, we will very quickly land by 3 major pillars, I would say, and megatrends, which are coming to the industry. And I cannot tell you more about, I would say, this projects we're doing or requests coming from a market, but I can summarize them in a major 3 areas we currently see as being a major shift in the industry and tremendous investment coming from companies in these areas. So I'm pretty sure we will feel and see the impact of these areas over the next years. One of them is the orchestration. So for people in this group who also working with LLMs, you can also give the tools to your systems and LLMs so they can trigger some actions and they can really understand the digital work. Yeah. So we have these LLMs as being an interface to our tools and systems, even in many areas where we don't have a proper APIs. On the other side, we have another range, and this is a physical world. And we heard already in the first keynote how strong and powerful are the visual action models, how powerful is this capability of having not scripted actions embodied in physical bodies of different robots, and how universal this reasoning component can become. And in the middle, we have, I would say, this joint pattern between the digital and physical world, and this is this reasoning capability. So AI can learn to decide, explain, and optimize across goals and constraints in the digital, but also in the physical space. So what will we need, and what does it mean for industrial if we bring these capabilities together? So for those of you who are in industrial space, you've seen the rapid development of the last years. So summarized, you can imagine as many of processes in the past were distributed across different disciplines, and it made the whole development cycles very complex because you have different languages, you have different disciplines and ways of thinking if you plan new production line or develop a new physical product. So we're moving more and more into the digital space where we use digital twins or digital representation of a product to iterate in a digital space before we take the costly changes in the physical product. And we can already detect a lot of conflicts in a virtual space before we're bringing to the physical one. So it looks smart, I would say, from a picture, and it makes kind of obvious that a reasoning layer in between would be super powerful, because then we don't have just a co-pilot within different pillars. We have a kind of a ChatGPT for the industry where which can follow you through the process and give you advice and optimizations. This is summarized my, I would say, personal impression of what's happening at the moment in the industry. We have started with basic text inputs 2.5, 3 years ago. Yeah, so everyone was fascinated by putting the data in ChatGPT and seeing how you can chat to PDF, chat to some maintenance logs. But the hunger of the industry and companies for AI is really huge. And it's not only the text, we're now working with all different dimensions and formats across images, videos, voice, structured, unstructured data, 2D, 3D data, 3D data over time, like in projects and drawings was seen in the first demo. And this is pretty amazing because it generates a lot of different outputs and use cases, but the major problem is still there. So we're now sitting on different disciplines, each of them bringing this co-pilot kind of thinking into their domain. You can imagine the product starts with some raw materials and goes over time over different stages. You start with a bill of material in the beginning. You have your requirements of the product. You have different disciplines working together. Now the point of software development is getting more and more crucial one. So we speak about software-defined products there. On the end, you have your product where your mechanical engineering, your manufacturing, your software engineering merges together in one product, which has to be tested, validated. You go to the documentation, and in the best case, you don't have to make any iteration. But if there are any changes, you basically start from start. Yeah, so going back to production, making some changes, and we loop it over and over, and you can imagine how many data, how many artifacts is being created there. So this process is being called digital thread. So the idea is that you can connect different disciplines and tool sets together, and you can have a continuous data flow and contingency across different platforms. So changes in a requirement can directly be validated in a tool which can simulate your product. So far to the theory, the practical reality was that this kind of approach is very hard to implement. Because we have different disciplines, we have different experts with different philosophy. You can imagine if you will have different experts sitting together, and one is a software developer, one is designer, the third one is responsible for building a machine, and the third one is, for example, from IT. And you as a client or product owner will say, like, my main responsibility or my main goal is that product will be safe. All of them will say something different. Yeah. So everyone will say, yeah, of course it will be safe, but of course all disciplines will understand something like different. And this is a major challenge in this complex industrial world, that today there are so many disciplines playing together as a team to make a product successful. So where is the barrier actually to bring these large language models and reasoning capabilities to this team? So the first one, as already mentioned, are these diverse domains and disciplines playing here together. So you cannot just have one chat window like ChatGPT and chat to all of them. So for those of you who are working in NLP or working with LLMs, you know this term of a context window. So you probably have experience that is pretty, I would say, tremendous and major requirement not to mix too many different topics in one context window, as the quality will be worse very fast. And this is already pretty visible in your, I would say, private experience. But if you bring it to the industrial, where have a very different domains and very different types of information, you will see the degradation of information very fast. The second problem, as I already mentioned, in some of areas like maybe customer support or coding, you can stay in your one window or in your, for example, coding environment. But in many industrial cases, you have to switch between different solutions. Yeah, so you have different tools for product lifecycle management, for requirement management, for simulation. So one context window, even having tools like MCP to connect to the data, is a step further. But still, you have to go very deep in very specific solutions, which is not feasible for now with one context window. And the third problem, which is very specific for all of you coming from different domains, you know about that. All of the tools have different syntax and different formats, which plays together. And also they are being constantly updated. So if we will try to train one super smart AI for industrial, this tool will face all these three problems. Yeah, it should be different for each domain. It should navigate through the media breaks and our fragmented tool landscape. And we would not like to train and retrain our model each time when we have an update on different formats and syntax behind, and they are being updated all the time. So through this conclusion, already last year, we came, I would say, kind of normally without anyone naming it as agentic to this agentic architecture. So our approach was to say, we will develop an agent for each of the step, but then comes the question how to make these agents working together, yeah? And here we comes to this agentic architecture. And I will not go, considering the time, deeply on this topic, but there is different philosophies, how you can organize these teams. And I think it's really fascinating because here we see many, many parallels to how we organize real teams in our companies. There are different paradigms. You can just research on the internet, and it's really fascinating because we can apply the same strategies we apply for different organizations, having a flat hierarchy or a very hierarchical one, all of them with their advantages and disadvantages. So for kind of ideation phases, yeah, where we ideate about the product, for example, I apply rather a flat structure where we have different experts working together. For cases like this one, where we have a structured process, something like hierarchy tree can be a better decision where we can really delegate different tasks to different agents, and how we call it utility agents, which performing the task. So This sounds like a theory, but actually we're already using that in several domains. And you can follow us on social media. So one of our major solutions in this space will be published in next week's. We call it AI Orchestrator. And one of its implementation is within the engineering domain. And you will see how it's able to perform the reasoning across all these disciplines. And one of a very practical example, you are designer working on engineering design, and you have a requirement of the tool, like, for example, a battery pack for a bicycle, and you get a requirement to increase the capacity of this battery cell. And you will see the grid of this product. And for example, if you say to our orchestrator, increase the capacity by 20%, you will really see how it reads the requirement to your tool in, for example, tool like Polarion from Siemens. It will see what requirements to different materials and thickness of this grid are. It will go to the CAD design. It will modify the design by its reasoning capabilities. It will validate the design in the hypermesh and hyperview, where we can really like simulate the tool and make some tests, like stress test. Yeah, so really if it will break or not, considering the requirements from a first tool. And if your results will be positive, it will give you a result. If not, it will start over again. So we're really implementing this concept of digital thread, but now using reasoning capabilities of LLMs as a major enabler, because now we don't have to have experts between each of the steps sitting there and just trial and error different parameters. The large language model can do that for us, and we can run it in a parallel as kind of a, if you know it, Monte Carlo simulation. Yeah, so running different parameters, for example, overnight, generating different designs, and then our experts can come in the morning, grab a cup of coffee, open their computer, and they will have hundreds of different designs with 3 of them, for example, passed the test, and they can pick up those 3 and start from there, just finishing it and improving it and finalizing it, instead of spending their time just with trial and error over different parameters to try to get to this past design. And I think this methodology will be super universal in many areas where we have routine work, not only in engineering, but basically everywhere, where at the moment you have different disciplines working together with these media breaks and different experts having knowledge on how to go through this thread. And actually, as we implemented that, we've seen there are many other advantages as well. So we not only solved the 3 major problems in the beginning, we can now have diverse disciplines working together as we have different chunks, different agents specialized on one step. The media breaks are not a problem anymore because all these agents kind of report to the manager on the top, and the manager don't have to operate each tool. The specific syntax is not a problem for us anymore, since each agent is specified or optimized for each specific syntax and can be easily retrained and updated. But there are many other advantages, like we can save tokens, we can have a hybrid setup, we can record macros and optimize some processes like robotic process automation in the areas where we don't have APIs in manufacturing, for example, where not each MS solution have a proper API which we can use, and of course not a MCP adapters yet. But this is not a bottleneck here. And we can even integrate best practices, for example, in these tools. So with agents, you can imagine kind of a ChatGPT in your company can help you with suggestions, incorporating best practices into these workflows. And you can imagine for large enterprise companies, this is a major point. And exciting part about that, it can run even in parallel. Yeah, so we can start someday very soon, several of these threads in the same time, and then putting in the GPU, run it's accelerated in the parallel and pick the results and optimize them. And this is a real game changer in many areas, which are compute heavy and rely on simulation. But our goal, and my personal goal, is to abstract this concept from different domains like engineering, manufacturing, supply chain, robotics, to a unified layer, as there are lots of work to be done. So it sounds kind of a mature probably for you. And of course, if you will follow the news, there are many updates on this topic. From my personal opinion, we are just in the beginning. So we see already potential. But for example, for IoT, it took 10 years to come from IoT to industrial IoT. So IoT was not different, but we had to create the whole framework around IoT to make it scalable, trustworthy, and industrial and enterprise landscape. So I see the same journey now happening for the topic of AI, and especially in the reasoning field, since you can imagine reasoning is not deterministic, and we have to create a set of rules and frameworks to make it secure, scalable, trustworthy, and transparent. So we are working on a concept which I call digital reasoning thread. So how we can bring reasoning across the digital thread in a scalable, secure, and trustworthy way. If you're interested, just follow our page or follow me on LinkedIn or GitHub. We are preparing to publish our first version very soon. And you can find it online. You can also contribute regardless if you are coming from startup or you are a developer or just a curious person. From my summary, I would say, regardless what you hear in the media, so I would say we're just in the beginning of the journey in industrial. It's not a hype. Most of the frameworks we currently use are just, like, for example, LangChain is 0.3. So normally we would not ship something like that to production, but there's no way because everything is just in the creation. So be part of this journey, join any, I would say, ship driving in the space, because I think there's a lot to be done. And if you're interested, just ping me, contact us, and let's shape the future of industry together.